So now that we have completed one-dimension K-means problems, we are going to move forward with the two-dimension ones. So here the question would be in a tabular format. Now another thing that you need to know is K-means, if it comes in the exam, it is only going to be for 5 marks. Data that they give would generally be a lot more smaller. So if suppose this is what the table is given to us, data A, B, C and D. So please excuse the entire thing. So this is given to you and you have to find the clusters for k equals 2. So that means you need to have two clusters, C1 and C2. So this is what you have to find. Now you start by assuming two centroid values. So I'll be assuming C1 to be equal to 4,3, that is this value here, and C2 be equal to 5,4, that is going to be this value here. So now, just like we have done in one dimension K-means, we are going to be considering what values in the database are nearer to the cluster or the centroid that we have assumed, and then we are going to work our way through from there, right? So I'm making the same table. So data x, y, the value that we had, and then for C1 we are going to calculate something, and for C2 we are going to calculate something. So data A, B, C, D, the values are 1, 1, 2, 1, 4, 3 and 5, 4. So how are we obtaining the value for C1? That is going to be 4 minus 1 the whole square. So basically you are using Euclidean distance formula over here. So that is going to be x2 minus x1 the whole square plus y2 minus y1 the whole square, and the entire thing is under root, right? So here I'm considering my 4,3 to be x2. You can consider it as x1 also. It would not make much difference because we are just taking the square here, right? So that would be 4 minus 1 the whole square plus 3 minus 1 the whole square. This is going to give us 3 square, which is 9, plus 2 square, which is 4. So 9 plus 4, we get it to be 13. The root of 13 comes out to be 3.6. Similarly, you do over here, that's 4 minus 2 the whole square plus 3 minus 1 the whole square under root of this, which is going to give us a 4 plus 4, which is 8, and under root 8 comes out to be 2.8. Next 3 minus, so this is going to give us a 0, and then we have 4 minus 5, which is going to give us 1 square plus 1 square, which is 2 square under root 2 is 1.414. We do the similar calculations over here for this value. So that is going to be 5 minus 1 the whole square plus 4 minus 1 the whole square under root of it. This gives us a 4 square, which is 16, plus 9, which is 25. Under root of 25 is 5. Similarly, solving for the remaining problems, this is the solution that I get. Okay, so once we have received the values, what we have to do is check which one is the closest to the centroid that we have decided. So we have to finally find the cluster. We have to put it in some cluster, right? So here the value is 3.6 and here it is 5. So 3.6 is smaller than 5, so this is going to go in cluster 1. Similarly, 2.8 and 4.2, this is going to go in cluster 1. 0, this will go in cluster 1, and this will go in cluster 2. So after our first iteration, our cluster 1 is having data points A, B and C, and C2 or cluster 2 is only having D. So now what we have to do is we have to find the new centroid value. So here we will write down the data points also. So that is 1, 1, 2, 1 and 4, 3 for your cluster 1, and for cluster 2 it is going to be 5, 4 only. So now because there are more than one values here, we will have to find one single, like a set of data points. So we'll do 1 plus 2 plus 4 by 3, 1 plus 1 plus 3. So this is going to be, you are adding up the x coordinates dividing it by the number of data points, and you are adding up the y coordinates, dividing it by number of data points. So the answer that you get over here is going to be 7 by 3, which gives us a 2.33, and this is going to be 1.67. So your new centroid points C1 is going to look like 2.33 comma 1.67, and your second centroid value is going to look like 5 comma 4. So now that we have this, we are going to be making the same table like we did over here for iteration number 2. So for I2 data, then we have got the values of x, then we have the values of y, then C1 value over here, and C2 is going to be the same as we had above, right? So that is A, B, C and D. The values are 1, 1, 2, 1, 4, 3 and 5, 4. And because C1 you will have to calculate, C2 I already have, so I'm just going to substitute their values over here. So I'm going to repeat the same procedure. So this is going to be something like 2.33 minus 1 the whole square plus 1.67 minus 1 the whole square, and you find under root of it. So the value that you get after solving this is 1.06. Similarly for this it is 0.85, 3.54 and 4.9. Okay, so now we are going to determine in what cluster which data set is going to go. So if you consider over here, 1.06 is less, so in C1 I will be having A. Here also B will come here. Here if you see there is a variation, C and D are going to go in cluster 2. If you check iteration number 1, in cluster 1 we had A, B and C, but now after iteration 2 we have A and B in cluster 1. So we will have to perform the third iteration. For that we will have to find the centroid value. So centroid value is going to be 1 for C1. Centroid value is going to be 1 plus 2 divided by 2 and 1 plus 1 divided by 2, which is going to give us a 1.5 comma 1. Similarly, C2 is going to be 4 plus 5 by 2 and 3 plus 4 by 2. So this is going to give us a 4.5 comma 3.5, right? So what we are going to do is we are going to calculate the values again for iteration 3, where we have the data points x, y, and we'll have to calculate C1 and C2 because the centroid values are different this time, right? So let's do that. So now that the table for I3 is also made, we can check here that A and B are going to go in cluster 1 and C and D are going to go in cluster 2. So your C1 would look something like 1 comma 1 comma 2 comma 1, and your C2 would look something like 4 comma 3 comma 5 comma 4. So what this means is that for clusters in I3 and your clusters in I2, you have got the same values. So as you can see that the clusters here are going to be A comma B for C1, and for C2 it's going to be C comma D, which is the same as the clusters in iteration 2. We can say that the final answer is these clusters for the centroid values of 1.5 comma 1 and 4.5 comma 3.5 respectively. Okay, so that is it. This completes your k-means, which comes under the partitioning methods for solving your clustering algorithms. K-means, you also, one thing that I wanted to mention is that when I was solving the question for 1D k-means, I have just written it in this form. So now you, for getting marks, please make a table and compare your C1 and C2 values, and then make another table which will show you the clusters just the way I have done here for your 2-dimension tables. Do that the same for 1D as well. Our university focuses a lot more on the format and how you are presenting the solution than just the solution. So if you just write it like this, I mean, this just has like four steps. It does not even have four steps. You're just doing two iterations and finding the center and then just writing this. So for 4 sentences you're not going to get 5 marks. Make a table and explain what you're doing in each and every step, just so that they would know that you've not copied it from somewhere and that you know what you have done. So yes, that is it for this video. Bye.